here we're revisiting the phosphorus cycle. And up to this point, what we've done was describe the soluble phosphorus pool and why plants only take up H2PO4 and HPO4. We've relatively ignored the primary minerals that contain phosphorus. These are apatites or calcium phosphates. These weather and end up delivering phosphorus to all these arrows that you see on this figure. We have talked about adsorption and desorption reactions with respect to phosphorus, and we have talked about precipitation of calcium, iron, and aluminum mineral phases, and you probably could throw manganese in there if you want to, although we didn't talk about it, but undergoes the same reactions as iron and aluminum. And we talked a little bit about dissolution with respect to targeting the optimal pH for phosphorus availability, which is right around pH 6.5. So what I want to do next is focus some attention on the organic phosphorus pools present in soils and mineralization immobilization reactions. So when we look at organic phosphorus in the soil, about 50% of the total phosphorus present is found in the organic phase. The other 50% is found associated with minerals and clays. And a very, very small fraction is in the soluble pool. And that's because if you've watched some of the previous videos, I've taught you that phosphorus in soils loves to be loved. It doesn't want to be alone. It is a lover. And it's loved by organic phases as well in our soils. So the forms of organic phosphorus that we typically can find in our soils are a range, right? There's not just one particular, there's a whole bunch of different types of phosphorus forms found in our soils. And roughly speaking, 10 to 15% or 10 to 50% of organic phosphorus are found in esters, right? And these include compounds like inositol phosphates, also known as phytic acid. Maybe some of you have heard of phytic acid. It looks like this down the bottom left-hand corner. Okay, here are some other inositol phosphates. Here's inositol, and you can probably see this structure here as phytic acid, which is inositol phosphate. Looks a little bit different than this picture, but it's basically the same, right? A lot of our phosphorus is found in this form, as phytic acid or inositol phosphates. Then we have some phosphorus in phospholipids. These are the cell structures or the cell membranes of microorganisms, of plant tissues, etc. And then we have a little bit in nucleic acid, so 0.2 to 2.5%. All of these forms of phosphorus are forms that plants cannot utilize, right? And this value, 50% of the total phosphorus in soils can be organic. That could be, it could be several hundred parts per million in a soil easily. While plants don't need that much, they maybe need 10 to 15, 20 parts per million, depending on the plant species itself. And so how do plants get these forms? How do plants see these forms of phosphorus? We're going to talk about that in the next video.